This video presentation is a demonstration of how to produce hydrogen from water. Let's first gather and assemble the needed materials. A common 1-quart canning jar will work fine as a container for the water. I picked up a number of other needed items at the local department store. A package of pencils, a pair of test leads, a pack of 9-volt batteries. We will also need distilled water, salt, and cardboard. We will cut a piece of cardboard from a cardboard box. First, I am pouring distilled water into the 1-quart canning jar. I want to make sure that the water is deep enough to sufficiently cover the graphite electrodes that I will immerse in the water later. Next, I want to pour about 1 teaspoon of salt into the water. Salt is a conductor of electricity. The salt in the water will help to conduct the electricity needed for the electrolysis process. Here I am stirring the saline solution to make sure that the salt is fully dissolved. Let's put the saline solution aside for a few moments as we prepare the rest of the apparatus needed for the demonstration. From this cardboard box, I will now proceed to cut out a piece of cardboard that I will use to suspend 2 graphite electrodes in the saline solution. We will come back to the cardboard strip in a few minutes, but first we are going to produce 2 graphite electrodes from 2 number 2 pencils. Using a hacksaw, I am cutting the eraser ends off the 2 pencils. The next step is to sharpen both ends of both pencils, exposing the graphite on both ends. I am using one of the pencils to mark 2 spots on the cardboard strip where holes will be cut. The graphite electrodes or pencils will be inserted into the holes in a few moments. For safety purposes, I asked my father to cut the 2 holes of the cardboard strip. He is checking to make sure that the holes are the right size for holding the pencils in place. It seems to work, so now I will insert the 2 pencils that will serve as graphite electrodes. Notice that the pencils extend further on one side of the cardboard strip than they do on the other. The longer end will be the part of each pencil that will be immersed in the saline solution. Now I am going to immerse the pencils in the solution. Nothing is happening yet, because we have not generated an electrical current. The next step is to prepare the 2 electrical test leads. Test leads are wires with clips attached to each end. One end of the test leads will be attached to a battery, and the other end will be attached to the upper exposed ends of the pencils. Electrical power for the demonstration is provided by a 9-volt battery. The black test lead is clipped to the negative terminal on the battery. The red test lead is clipped to the positive terminal on the battery. Now I'm going to attach the other end of the leads to the exposed graphite on the upper end of the pencils. The red test lead is on the left. It will carry currents from the positive side of the battery. The positive pencil electrode is referred to as the anode. The black test lead is on the right. It is attached to the negative side of the battery. The negative pencil electrode is referred to as the cathode. Everything is ready. All the connections have been made. Now, if everything is working as expected, electrolysis should be taking place. The camera has been moved to the back side of the display to get a better shot, meaning that in the image on the screen, the cathode and anode are now reversed. The cathode, or negative electrode, is now on the left, and the anode, or positive electrode, is on the right. Note that already gas bubbles are forming and being released from the graphite tips of the pencils. The bubbles forming on the cathode on the left are bubbles of hydrogen gas. The bubbles forming on the anode on the right are bubbles of chlorine gas. The chemical formula for water is H2O. Water is made up of hydrogen and oxygen. Normally one would expect oxygen to be the gas forming on the anode. However, because of the salt or sodium chloride that is in the water, it is chlorine gas that is forming on the anode on the right. So there you can see it on the left. We have successfully produced hydrogen gas from water.